Okay, let me walk through the process of creating a new HMI file. And we're going to create that file for the 2.4-inch screen. So I'll click on New, and it wants a new project. I'm going to let me find a good spot for it. Well, that's a good spot. I'm going to call this New Setup. New Setup. Okay, and it's a 2.4-inch screen, the basic series. Because of the way it's going to be installed on the circuit board, it needs to be a 270, which is like upside down. What that will do is it'll locate the micro SD socket on the top side of the board so it's accessible. So we'll click on that. There's my blank screen. I don't have to change the background color, but I like to make it a dark color because it's like easier on your eyes. So there's a dark black color. The next thing I'll do is I'll create a font file so that it can print characters to the screen. And I think just for now, let's go with the 48 font. It's pretty large, but it's okay. So I'm going to call this new setup 42, 48. Okay. Wants to save it, so we'll save it. Add it to the program or to the project, we'll say yes. Okay. And you can see that here if you click where it says fonts, you can have a look. There is font 0, which is new setup 48, and we're all set. So let's put a numeric indicator on the screen. Okay, N0. So one thing you can do is drag the box to resize it if you'd like to do that. You want to make sure it's large enough to contain the values that we're going to send to it. So I suppose one way you could check that out is if you justify the value, and then if we load it up with zeros, let me look for that setting here. Space. Let's see if that does it. No, that's not it. Length. There we go. So we could just, let's say we're going to go from 0 to 1,000, then that's wide enough. If I go 5 spaces, 0 to 10,000 or so, we were planning on 0 to 1,000, so let's just resize it so that it will fit, just to be on the safe side. We don't want to have it too small and then it comes out wrong. Okay, so let's leave it just like that. Let's add some text to it, and the text is going to say my value. Okay, so we're going to write a value to the screen called my value. We're going to justify that as well, and try to make it look as close to the other one as I can. And the new text will be called my value. Okay. Notice right here the text length right here. If you need more space, you can add additional characters right here. So the maximum length for this is 10. I can't squeeze 10 characters on the screen because it's too small. But anyway, so now I've got a numerical indicator called N0, and I have a text called my value. Okay, that's all there is to it. So let's say I want to save this. I'm going to save it. And the next thing I would do is export it to the flash card. I'm going to point to the flash card, USB drive E, and I'm going to save it. So now what I've got is I've got my file on the flash card ready to go. I've got the project in here. It's finished. It's a basic setup for one value, right? And the next step is to move the flash card, the micro SD card, to the to the screen, reboot it, it will load the software and run. So I made a video earlier that I will attach to this video. You can see the results of that. It's not exactly the same as this one. I think I'll make a new one, in fact, so they match up. So I'm going to close this video and we'll attach the other one to it. Okay, so here's an updated video that shows loading the nextion file, which is on this SD card, into the screen. And I've got a controller that I've pre-programmed with a short program. All it does is generate some numbers and send it to the screen. It's generating 3 numbers, but it's only going to show 1 because we set the screen up with 1 numerical indicator. So a closer look at the connections here will show that I've got a ground connection down here on the bottom of the Arduino. So that's my negative, the black wire. The red wire goes in right here, which is a positive 5-volt connection. The yellow wire is the receive wire for the screen, which means it goes into the transmit pin of the Arduino. So TX sends data to the receive pin, which is the yellow wire. The blue wire we're not really using, but it will send data back to the controller to RX. So we'll eventually use that, just not right now. So what I'm going to do is I'm going to go ahead and put the SD card into the socket. Power is off, so what I'm going to do is power up the controller, and let's watch the screen here. It's saying that the card is detected and it's updating the program, and it is successful. So that's all I need to see. I'm going to power down or remove the card. I'm going to power back up, and it should start to display numbers. Okay. So I had to reboot the Arduino. That's the second time I've had to do that, and I'm not sure if it's because the cable that I'm using, it's like communicating to the laptop, or if it's just because it didn't boot up correctly. I've noticed that if I use a battery source, a power source, instead of the computer to power the card, it tends to work better. So there may be some communication issues where when it sees the computer, it tries to talk to it, and I'm just not 100% sure about that. But if I reboot it, if I press the reset button, it should go back to 0, 1, and it's counting up. It's counting seconds basically. So that's the process. You use the nextion program to generate the screen layout that you want. Then you upload it to the card. You set up your program to send data to that numerical block there, and it updates it for you. I can actually change the text that you see on the screen as well, because the text is T0 and it has a value. So I can update the text as well. I can update numbers, text. A lot of different objects can be updated on the fly. Okay. You can even change background colors and a whole lot of different things. Very flexible. The trick is to find the right command, and that's not always so easy, but you know, their help section is a little rough, but it's okay. So that's the process. The nice thing about it is that it's in Flash, so every time you boot it up, it's going to come up, and it should start to work. I'm really surprised that it's not, but when I hit reset, it does start to count. So eventually I'll try this with a power bank and see if the problem goes away. I've noticed it not only on this is actually an authentic Arduino card, but I've tried it with some other cards like the, well, I don't want to name them, but but they seem to have issues that they're trying to talk to the computer, and it kind of interferes with it. But if I put them on a power bank, which is just straight power, it works fine. So I'll try that out and see how that works, and maybe put up a video for that too.